Okay, let's go ahead and get started. Welcome to the annual meeting of the Alachua Astronomy Club. Our bylaws indicate that this November meeting is called our annual meeting. It's a little bit different in that we show you the finances, but we also have our annual elections, so we'll be doing that this evening.
I'm going to bring the microphone over to you.
Okay.
I apologize for not doing that.
And there's our schedule. Looks like most, except we've got added the elections and finances in there. And then Rich Russin, who's back in Maryland. He'll be doing the Members Corner this evening via Zoom.
Testing.
And then after the break, James will do a planetarium show titled Stars of Autumn.
Yeah. Okay. Yeah. So I'm going to, during dinner, I decided I'll show you two small pieces of glass, which is about telescopes and stuff, and then I'll bring up the Chronos and I'll show you the night sky. Because I decided to do that so that people at Zoom have something to look at. So they'll get to see two small pieces of glass, and then we'll continue with the Chronos stuff because you can't see that on Zoom, unfortunately. Okay. So.
Testing, 1, 2. Can you hear me?
John, is the volume up?
Can you hear me?
Oh, did I mute it? Oh, is it muted? It might be muted.
Did you mute it?
Okay.
Testing, 1, 2, 3. Okay.
Okay, a little louder.
Testing, 1, 2, 3. All right.
Okay, let me move this away from your chin a little bit. There you go.
All right. Thank you. All right. We have some new members since the last time we met. Rebecca Dene, are you here? How about Heather Dunbar? Dan Perez? Andrew Peters? Now that's your nephew, Matt, right? Okay. Elin Powell? Jared Revels? Maria Rivero? Tina Sessions? And a new member as of today, Robin Wargle. Hey, okay, there's Robin. And we are up to 216 members. Do we have any visitors here tonight? Yes, sir. Your name?
Christopher Malagna.
Welcome. Well, we hope you come back. Okay, as usual, a small handful of AAC members supported Astrofest, and of course, some of the co-owners of the property ran and organized Astrofest, and it was a huge success. Lots of folks came from all around the country with their RVs, campers, and tents for some really dark skies. Is that me making that noise?
Yes.
Stop.
Okay. Yeah, Andy gave a really great presentation on how he used his C-Star to capture eclipsing binaries. That was fascinating. And then Matt outdid himself by a factor of more than 2 on all of the donated goods from a lot of astronomy companies, up $23,000 worth. And of course, those were all raffled off. You can see the raffle team there is Richard, Matt, and Lisa, and then Ed helped out with some photography. It was a huge success. And of course, we had the swap meet, and Matt put up our club sign as always. And there is the very small array group. We have some there from our club, St. Pete folks there. Is that right, Matt?
Yeah, coming from all over.
Okay. And as always, some really amazing equipment. These folks take some serious astrophotography and do amazing things. And you know, it takes a lot of work to put on an Astrofest, so a little wine afterwards isn't too bad. There's Jerry. Tell me the name of that dish again that you made, Jerry.
Chicken tikka masala.
Oh, that was so good. And then there's the chocolate chip cookie crew. It's missing Sarah and Gay, but that's the production line. Joe is quality control. He grabs one every now and then. just to make sure we're,
The hardest job of all of us.
yeah. Okay, what do we have coming up? Next start party is on Friday out at Chiefland, and it's early now. So if you're setting up a scope, get there at least an hour earlier than sunset. And as always, you get a no email by noon that day. Same evening, Terry Oswald's having their open house over at Embry-Riddle. So if you're over in the direction of Daytona Beach, those are worth going to. Okay, community open house got canceled this last Saturday, but going to try again this coming Saturday. And let Lisa know. She's going to do another head count on who's bringing their telescopes to support that. So let Lisa know if you can participate in that. Okay, and I'll be helping on STEM night at Archer Elementary. I could probably use one more person to set up something inside a booth with a few scopes or whatever, and then we'll put a telescope outside where one of those arrows. So if anyone would like to help on Monday, let me know.
Let me meet you for a second. Let's switch batteries real quick.
Okay. Where is your microphone?
There you are.
Okay.
Okay, you can put it in your pocket if you like.
All right. Okay, sorry about that. We had to swap batteries in the remote microphone. Okay, on the 19th, Estrellas is having their next event at First Magnitude. Dr. Alexandra will be talking about the humanity and spaceflight being the final frontier. They'll be talking about what physicians will do in space to support those activities. Okay, I have not heard back from Miss Atchison on this, but if it's still a go, I'll let folks know if we can. I can do it by myself, but if decide that might need someone, I'll let you know. Okay, holiday party coming up next month. It's on Sunday, December 7th, 6 p.m. Same location as last year, the Village at Gainesville, a wonderful facility. And again, it'll be a potluck dinner. The club is paying for the ham, turkey, and beverages. And being it's a potluck, Jerry will bring that dish again, or something really good. But bring your favorite dish, and we're going to play a game or two. It won't be that really difficult space quiz that Rich wrote last year. That was really hard. RSVP at the website, and at the same time indicate what you'll bring to the potluck. Okay, next Faro Journal Club, December 9th. Terry will host that with James Albury and Dean Regas. You've seen this slide before. And then the final star party at Chiefland, that's December 13th. Okay, Jerry, would you like to say a few words about our finances?
I've just recently become the treasurer, so I'm still getting up to speed, but we had a board meeting last week, about a week ago, and so this table just shows what our expenses have been, income and expenses for the last 3 months, and fortunately we're making more than we're spending. That's always a good thing, and so we're doing okay right now. And this gives us a picture for the last year. So the important thing would be to look at the opening balance over there of 20, what does that say, 21,184, and then over here it's 26,664. So we're about $500 less than we were at this time last year. But we did spend a lot of money this year on some good things, scholarships and telescope restorations, but we're still in business, so things should pick up after the new year, and we got some new dues money in. Anybody have any questions about the club's finances?
Thank you. Okay, it's time for our annual election. The nomination committee provided these nominations. And before we actually vote on these, and I highlighted in yellow what the new positions are that are nominated, are there any nominations from the floor? Okay, having heard none, we give our vote with our hand. So all in favor of this lineup, please raise your hand. And anyone opposed? Okay, and Matt and Jerry, would you stand up so some of the folks might be newer here. They might not know who you are, new president and vice president for next year. And for our coordinators, Orlando will take over programs from me. I've been doing it for 4 years, and that's the person that arranges for all the speakers, both guest speakers and members' corner speakers. And then Tom is going to take over ATM from Matt. If you two guys would stand up as well, please, Orlando and Tom. And are there any nominations from the floor for coordinators? If not, all in favor? All opposed? All right, congratulations. Now, I volunteered to do school outreach on the library telescope program because we haven't been doing much of that lately. In my humble opinion, the most important and meaningful and impactful thing that we can do is influence a young person. And that person might become an amateur astronomer or a professional astronomer or something like that. So I think that's a big deal. Here's an example of a young man who was influenced early on, Al Nagler, and we just lost him at the end of last month. He was one of the giants in the amateur astronomy world. He was a member of the Junior Astronomy Club sponsored by the Hayden Planetarium. That's the one that Neil deGrasse Tyson is in charge of. And he ground his own 8-inch mirror and built a Newtonian. And he wrote an article, and it was in the December 1955 edition of Mechanics Illustrated. And there's the first page of that, so that was 70 years ago. And he did a fantastic job, and then he competed in the Vermont Stellophane Convention and won third prize on that. So then you wonder, okay, well, what became of that? Which path did he go down? He became the chief optical engineer for Keystone Camera Company. Some of you might remember Keystone cameras and projectors and movie cameras. He also built simulators used to train the Apollo astronauts. And then he founded Teleview Optics in 1977, and he invented the Nagler eyepiece in 1979. How many of you have or have used Nagler eyepieces? They are really good. I mean, they are top-notch, the standard. They are outstanding. And he stated when he worked on eyepieces and telescopes, he had two major goals: to make astronomy as easy and versatile as possible, to encourage rather than discourage newcomers, and to provide a visual experience as close to a spacewalk as possible by obtaining the widest, sharpest, highest contrast views. And those who've used like a 2-inch Nagler and a big light bucket telescope, that is so true. And in 1993, asteroid 10715 was named for Nagler. It was named Nagler. So he done good, and we'll miss him. Okay, any announcements from anyone? Yes?
We have some free stuff outside. This gentleman here.
There's about 4 tripods outside. One nice little one for standard camera, 2 big ones. I think video stuff can go on them, but hey, telescopes or whatever you want. And one surveying one, but it's also big, so help yourself.
Great, thank you. Okay, it's not intermission time yet. I got my slides flipped around. So now we're going to do Members Corner with Rich Russin. He's going to talk about H.H. Ninninger, Master of Meteorites. So let me see if I can do this without screwing it up too bad here. I might need James's help.
So, is, okay, is Rich on?
Yes.
Dave, can you see my screen now?
Okay, you stop sharing and let him share.
Where do I stop at?
Okay,
Right
yeah.
there? Yeah, okay.
Okay, Rich, you should be able to share.
Okay. Share and share screen 2. Share. Okay. Are you able to see it?
Yep.
Yes.
Okay, I'm ready to go.
The microphone for the
Hmm.
dome.
All right. Thanks, Dave. Good evening to all of you back in Gainesville. I do miss everyone and wish I could be there in person for the talk, although I understand it's not a whole lot warmer than it is up here in Maryland. Tonight, I want to tell you about a man who I'm guessing most of you have never heard of prior to today, Harvey Ninninger. I became aware of Ninninger as a result of my interest in meteorites. In the mid 80s, I found a meteorite but paid little attention to it until 30 years later. As I started to acquire a small collection and learn about them, one name kept coming up in the historical references, Harvey H. Ninninger. And tonight I'd like to show you why he was so important to the study of meteorites. So let me go over here. Okay. And why won't she? There we go. Okay, let's start with this slide and the quote. Do with your life something that has never been done, but which you feel needs doing. And I put that quote out there. It comes from his autobiography, and it just totally summarizes his life. He, at one point in his life, saw a vacancy and decided he would fill it, and he did. And he lived 99 years. I'm going to tell you about what he accomplished in that time. Okay. His early life, though, was first 20 years was basically that of a farm boy. He lived and worked on a farm in a very religious household, and thus education was minimized. However, in 1907, he took a job at an orphanage and started to meet people who were educated and decided it was time for him to also become educated. He did have a strong interest in outdoors and nature and natural scientific curiosity. Thus, it was no surprise that 10 years later, he had his master's in biology from Pomona College. Now, World War I ended in 1918, a little bit of a transition period, but in 1920, he accepted a teaching position at McPherson College in Kansas teaching biology. And it was there in 1923 that at the age of 36, a series of events started a major change in his life's pursuit. The first one was in 1923. He liked scientific journals, and the one Scientific Monthly in the November article by Arthur M. Miller was on meteorites, which Ninninger was not familiar with. I dug around and I eventually found a copy of the article, and have to tell you, it is an excellent article despite its age. In the middle here, I'm hoping you can see the pointer. Can somebody give me a thumbs up to let me know that the pointer's working? Good. Okay. Here's some of the meteorites that were discussed in the article, and basically, it's just an excellent introductory article for its time. Next thing that happened was that on November 9th, 1923, Ninninger was outdoors with another professor at McPherson College when a large fireball crossed the sky. It actually exploded and broke into fragments and created a blinding light, and it just totally enthralled him. He had lots of questions immediately, like, where did it fall from, where did it land, how high was it when it exploded, etc. And he spent the next 7 years of his life transitioning from teaching biology to studying and collecting meteorites. I do want to point out an interesting field trip and the reason for it. Ninninger really didn't care for classroom study all that much. He felt it was mostly an exercise in memorization. So he liked to do field trips and labs and hands-on things. He arranged a trip in 1927 to 1928 for his students that they would get college credit at the end of the trip. And they went across America, started at Yellowstone, and then at this particular point, They were at the Smithsonian Institute. He took time out to meet with Dr. George Merrill, who was the head curator um, of geology at the time, and asked him about starting a field program with the idea of recovering meteorites, but anything they recovered would go on display at the Smithsonian. Merrill replied, if we gave you all the money your program required and you spent the rest of your life doing what you proposed, you might find one meteorite. Well, Ninninger said, next time you see me, I'll be selling you a meteorite. And as it turns out, a couple of years later, Merrill bought two meteorites from Ninninger. By 1930, Ninninger just decided he had to devote full time to studying and collecting meteorites. Interesting story here. He wrote to the Denver Museum of Natural History and proposed that he bring his collection of meteorites up there for display, and in return, they would give him a job with a nominal salary he could survive on. Rather than waiting for a reply, he packed everything he owned, his collection, his family, and he moved to a row house in Denver. Now, long story short, it worked out. One of the things he did is that he opened something called the American Meteorite Laboratory in 1937. This was actually a shop where they could cut stones and prepare samples for study or for presentation. Now, this was going well, but World War II came along and basically sidelined the kind of trips that he was doing and collecting until shortly after the war. During the time that he was doing all this, he spent some time at Behringer Crater, now also known as Meteor Crater, and at the time was known as Coons Crater. So basically, while he was there, he noticed that this building over here on the right was available. And he and his wife decided to lease the building for their own purposes. It was previously, the building was used for the Meteor Crater Observatory by Harry Locke. It was actually constructed in 1936 and it lasted 3 years. And the problem was this was in the middle of the Great Depression. Um, it's just really kind of sad, but that's the way it happens. Now, over here in the museum, I'm hoping you're seeing the pointer. The front of the museum here is pointing north, and this area down here was the main area for exhibits, the curio shop, and souvenirs and stuff like that. Up here, again, this is facing north. If you look to the south, about 5 miles or so south, you could see Meteor Crater from there. The idea was that people could go up there, pay a quarter, and get a view. If you look to the northwest, you would see the San Francisco peaks. And if you look to the southeast just a little bit, you can see the sands of Painted Desert. So note that this was actually just off Route 66 at that time. And thus on October 19, just 3 months after leaving Denver, the American Meteorite Museum was open. I found this picture showing one corner of the museum and many of the specimens that were in it. Just incredible what his collection was already at that point in time. However, it rapidly fell on hard times. Up here in this picture, you can see this is Interstate 40 here. This was built and it moved the road from, this is Interstate 66 right here, and it moved it north, and it basically killed the traffic, the drive-by traffic. This is where it was originally located. So you see Route 66, short dirt road, and it was there. And down here, I just did a quick thing to show you. Here at the museum, and when you look south, there was Meteor Crater. It was just an ideal location. Well, they did okay for a little while, but by 1951, it was just down to Ninninger and his wife. They were stuck for 2 more years, and they couldn't leave until July of 1953. Today, if you were to go by, this is what you would see of the ruins. You really can't get any closer as it's now owned by the Bar Ranch, and a security detail will greet you if you hop the fence. I did take this picture in 2023, and it was taken with a long telephoto, but you get the idea. It's really just a ruin now. So they packed and they moved. In September 1953, the American Meteorite Museum open. Question is where? This in the autobiography, they show a picture like this, and it says the American Meteorite Museum opposite Meteor Crater on Highway 66 in Arizona. Well, all you got to do is look at it for a second. You know that is not anywhere near Meteor Crater. Turns out it's actually in uptown Sedona. And the interesting part is it's now part of a Best Western resort. In 2023, Millie and I went in to the front desk and we asked to see the Ninninger wing, which I knew to be 3 suites here. And nobody knew what we were talking about. We tried telling them a little bit at the time, and it is clearly evident they owned a museum, renovated, but nobody knows the history of it. I just find that to be a very sad commentary. Um, so, problems again. Very quickly became obvious that Sedona could not sustain the business. You have to realize this is back in the 50s, and Sedona was just a budding town. They didn't even have electricity in a lot of areas. Water just been found in an aquifer under West Sedona, and it just wasn't enough to support them. At that point in time, Ninninger made the decision it was time to sell his collection and to get out of the museum business. So in 1958, he put his collection up for bid, but the first places he wanted to sell to was Arizona State U and then the Smithsonian. He wanted to keep it in the state first and the U.S. second, and it didn't work. And the British Museum of Natural History actually came up with a bid of enough money to induce him to sell. He sold 1,200 specimens for 158,000 roughly, which is about 1.6 million in 2023 dollars. He then used that money for a couple of things. One of them, he went on a world trip visiting other meteorite sites, not in the US, but it remained up for sale for the remainder of his collection. Arizona State was really determined to keep the collection in the state of Arizona. They raised the money and they bought it for $275,000. As you can see, it's about 2.8 million 2023 dollars. And this collection contained material from 684 documented falls. Well, the interesting thing is now that meteorites are popular and sought after, that same collection would sell literally for hundreds of millions of dollars. One of the things he did with his money when he sold it to the British group is they built a home in Sedona, and appropriately enough, it's on Meteor Drive. I drove by, but I really didn't have the heart to knock on the door and ask questions. But I do know that it was on the list of registered historic sites, and I put a little mini picture here of the plaque. It's actually on the building itself, not on the driveway, but I just thought I would show you. And that is Ninninger with his wife Addie in the top picture. He died on March 1, 1986 at the age of 99. He passed less than a month after the last appearance of Halley's Comet, and it was something that was really important to him to see it. I note that minor planet 2421 was named after Ninninger, and the mineral Ninningerite was named after him. It actually kind of looks like a meteorite. So let's talk for a second about the science of studying meteorites. First of all, it's not meteorology. It is the study meteorites called meteoritics, related to geochemistry, mineralogy, and cosmochemistry. And if you study it, you are a meteoriticist. It was Ninninger who really opened the eyes to the scientific community about the relative abundance and the strong value of studying meteorites. Have to remember, he did this during a period of time when the whole concept of stones falling from space was not widely believed like it is today. And he has thus earned the title of Father of Modern Meteoritics. So, what did he contribute to science in roughly 47 years? 162 scientific articles, 10 books on meteorites, and by 1941 alone, his personal meteorite collection was recognized as half of the known world collection of meteorites. By selling his collection to ASU, it became the foundation for the Busick Center for Meteorite Studies, which is world recognized. And he and his wife Addie provide an endowment for an annual meteorite award for students to continue studying meteorites. Now on the right is a picture of a little booklet that Ninninger did. Comet Strikes the Earth. It was about the Behringer crater. I did pick up a copy of it, and it's really kind of interesting because what he did, he sold these in his museums, and you can see here he actually cut out a circle all the way to the back page, and he included a meteorite fragment that was collected around the rim of the canyon. If you get into this kind of thing and you want to collect them, there were 4 editions, collect the first and the fourth. So this was the book that got me started. I'd started hearing about it. It was his autobiography documenting his lifelong experiences, first published in 1973. Problem was, it took me 2 years before I found a copy I could afford that was also readable. And it's going to be hard to recommend trying to do this because now it's probably going to run a couple $100 just to get a good readable copy. One of the things I want to point out is not only was he an excellent scientist, he was an exceptional writer. Reading his book was truly a joy. So what happened, there was a huge demand for the book, and his family, his descendants put together a revised edition that came out just recently, November 2024. It was a re-release, an expanded edition of Ninja's original autobiography, and it's now 576 pages versus the original 254. Now, of interest, the original manuscript he submitted was over 1,500 pages, so I think we're at a compromise there that works. Finally, if I could recommend one other, it would be the book H.H. Ninninger, Master of Meteorites, from which I borrowed the title of my presentation. It was published in February 2023 and written by Ken Zoll, who's now Director Emeritus at the Verde Valley Archaeology Center, and that's in Camp Verde, Arizona. Millie and I have met with him many times, and I've been on a couple Alachua Astronomy um, outings with him. And I can tell you it's an excellent book with a huge number of archival photographs. I highly recommend it. The proceeds from the book go to support the museum. So that's what I have to say about Harvey Ninninger. I think he earned his title as the Master of Meteorites.
Don't go too far. We want to see if we have any questions here. Are there any questions that I can relay to Rich? I have a question. Did Mr. Ninninger find maybe half of what he had and purchase the other half, or what? How did he acquire so many?
That's an interesting question. The reason he was so good at what he did collecting is because when he went out, nobody could find meteorites, but he went out, he educated farmers who he knew worked the ground and would recognize a stone that was unusual. And he would go out to classrooms, whatever, and he would go out and he'd teach people what to look for. Well, the next step was he then started buying them, but he paid kind of a small amount for them, and word got around, and very quickly people started calling him with meteorites to buy. I'm going to guess he bought the majority of his meteorites over time.
Okay. All right. Well, thank you so much. I will mail you your €2 Galileo coin. Okay.
Okay, thank you very
Oh,
much.
we do have another question here. What's the question? I can relay it.
Yes, I
We're
was
having some trouble hearing you.
for research and readings. Have you found out why large meteors tend to explode just before they hit the Earth? Is that because of the extreme temperature difference between outer space and when they hit the atmosphere?
Okay, the question, I don't know if you heard it, it was with regard to large meteorites, what become bolides when they explode in the upper atmosphere. Is that just because they're so big they create more heat before they become a bolide and explode?
Okay, hold on one second.
The very large ones who explode, why are they exploding?
Oh, okay. Yeah, we're having some trouble hearing, but I got my wife helping me. They do explode because the heat. They get to a very, very high heat. When they enter the atmosphere, they're anywhere from 26,000 to I think like 150,000 miles an hour. In fact, roughly 90 to 95% of all meteorites burn up before they hit the ground.
Did that answer your question? Okay, any other questions? Okay, can you bring the lights up a bit? Okay, let's go ahead and take our 15-minute refreshment break. Joanne's got some goodies right outside the front door. A reminder, don't bring any food or drinks back in here. And be back in 15 minutes and we'll get a show from James. Thank you.
Okay, everybody on Zoom, we're back. So I wanted to share with the audience, since Rich just did a presentation on meteors, or meteorites. I'm going to try to aim this down at the our meteorite. This is our fragment of the Campo del Cielo meteorite. And I put my little LED light in there so you can see it. I'm going to have to turn that off before you start the show. But you're welcome to come up and take a look at it. You've probably all seen it before. We used to take the cover off so you could hold on to it, but we don't do that anymore. So it fell in Argentina about 5,000 years ago. And it was approximately about the size of a Ford F-150 when it hit the atmosphere, in estimating the mass of this and all the other pieces. And it broke into many pieces, and you'll see regmaglyphs, which are these little divots all over the surface. That's where big chunks of it broke off. And it landed just outside Chaco, Argentina. And the people who lived there call it the field of the sky because they noticed the rocks were all very, very dense. This fragment is 92% iron, about 6% nickel, about 0.5% cobalt, or something like that. It's like 7. It's 92.9% iron, 6.7% nickel, and 0.4% cobalt. So, and it weighs 34 kilograms, which is about 75 pounds, which is heavier than most of the school children who visit the planetarium. But they're mostly made of water, so they take up a lot more space, and they're a lot more active than this. But when I used to take the cover off, they said, "Oh, what's that smell?" Is that because we had to spray coat it with rust repellent? No, rust-resistant spray. You know, to keep it from rusting because it's iron. So in our atmosphere, it would oxidize instantly. Well, not instantly, but it would oxidize very quickly. Yeah. So that was created inside a star at some point in its life. Silicon is fusing into iron and nickel and cobalt. And after a day of fusing iron, or fusing silicon to iron, the core violently collapses on itself and the star goes supernova. Yay! So, oh yeah. If you'd like, each of you can come up and take a look at it while I go ahead and talk about our next planetarium presentation. So, I'm going to be showing you two presentations. First one is two small pieces of glass, which was produced in celebration of the 2009 year of astronomy. That was 2009, yes, so it was like 16 years ago. We need another year of astronomy, I think. But the show talks about basically how the telescope was used for astronomy, because in most disciplines in science, you actually have a physical thing you can study. Like in geology, you can look at rocks. In biology, you can dissect animals. Chemistry, you have chemicals to play with. Well, carefully play with. But in astronomy, the stars are too far away, and the only way you can really tell anything about the star is the light that you can receive. And being at the bottom of an atmosphere, a lot of the really cool wavelengths of light we can't see because our atmosphere filters out gamma and X-rays, and for the most part ultraviolet. And so we can look at infrared radio and microwave, but the scary stuff that would kill us, we don't see, which is good, because if we could see it, we'd be dead. If on Earth, the surface. So anyway, we had send telescopes and stuff up there to do that. So that is about, that show is the first one you'll see. And then the second one, I'm going to bring up our optical mechanical projector, and I'll give you a quick tour of the night sky if you're looking to go out and look for things, because this is a good time to go look for the Andromeda Galaxy, if you've not seen it. and Dave's telescope here. That is Edwin Hubble, and he used this telescope, not this actual one, but the real one, to look at the Andromeda Galaxy for the first time, which determined, hey, it's a big spiral galaxy, not a nebula. So, yeah, it's amazing what you can do with a telescope. So I will show you where the Andromeda Galaxy is in the sky. And isn't technology wonderful? I can put a tiny little light inside a box. My wife ordered a ring holder from Amazon because our daughter, we would like her and her boyfriend to have a more permanent relationship. So her boyfriend, I gave him my blessing to marry my younger daughter. So inside the ring holder, Kendra had given her original wedding band and engagement band that I gave her 20 years ago. She put it in this little thing to give to him to give to her. And when you open it, there's a little LED that shines on the diamond ring. And I was like, wow, that's really cool that they can put an LED light in there. But I digress, because I'm just talking about my family and stuff. So those of you who are on Zoom, you can stay on Zoom and watch two small pieces of glass, but once we start the Chronos part, you won't be able to see anything because it'll be too dark. But that's okay. You're welcome to stay and listen to me jabber. So, for those of you who have never been here before, what you're about to experience is an immersive experience where our projector in the center of the room is going to project visuals over the entire surface of the dome. So there are times where you may feel as if you're moving because of the way everything is projected. So if at any point, if the visuals become overwhelming, all you have to do is close your eyes for a few seconds or look at something in the room that is not moving, like the chairs in front of you, and that feeling will go away. So, John and Kara, are the front doors secured? Not yet. Okay, thank you. Let's see. Also, the emergency exits. We have two emergency exits. There's one over there to your left, and there's one here to your right. So if you can do that, I've seen that before. But if at any point we have to leave the building, I'll bring the lights up, and you go through either one of those doors, and just walk down the short hallway, open the doors, and that puts us in the rock cycle garden behind the planetarium. And the show is only 20 minutes long, and then the Chronos part I can modify. But I'm trying to get us all out of here by, what time is it now? 8:07. 8:07. I'll try to get us out of here before 8:50. Yeah, I'll be quick. I'll speed up. And Lieutenant Commander, thank you very much for your service to our country. And I love the uniform. Yeah. So happy Veterans Day to all our veterans. So, thank you. All right, so, is everybody ready? Yep. You excited? Yep. All right. So, off we go with two small pieces of glass.
can see. Okay, we'll wait for your eyes to get used to the dark. Ow! Why is it so dark in here? Because we rode in from the bright lights of the city using the dark of the park. The pupils in your eyes are slowly opening up right now to let more light in. Just wait. You'll be able to see well enough soon. Is that why owls have big eyes, so they can see at night? Yeah. The larger the pupil, the more light it lets in. And that's why they can hunt at night. The telescope we're going to look through works the same way. The bigger the mirror or lens, the more light the telescope captures. Last year, they had a telescope that was big enough that I got to see galaxies. It was really cool.
Hi guys! I'm so glad you could come. I was looking for you.
I see you brought your big telescope this year.
Yes, I did.
No way. That thing is huge. And it sure doesn't look like the telescope in our science classroom at school. The eyepiece is at the back. Where's yours? It's at the top. That's why we need the ladder to look through it.
That's right. This is a reflecting telescope, which means the light is gathered on a mirror at the back of the telescope and reflected to the front of the telescope, where it hits another mirror and the light is reflected again into the eyepiece. The telescope your teacher has is called a refractor, that uses lenses instead of mirrors to gather and focus the light.
Which is better, the reflector or the refractor?
It depends on what you want to observe with your telescope, but the general rule is the bigger the mirror or lens, the more light the telescope will gather, and the brighter and more resolved the object you are looking at will be.
Resolved? Well, to resolve an object means that you can see detail. When you look through the telescope from our school, you can see Jupiter and its 4 moons. But when you look through this telescope, you can see the bands of clouds on Jupiter. So, the better the resolving power or resolution, the better the view, right?
Right. You have a great memory.
How could I forget? I will always remember seeing Saturn's rings for the first time and the spiral arms of that galaxy you showed me last year. Can I look through your telescope?
Absolutely. The whole reason I brought it here.
Wow, is that really Jupiter? And what are those stars lined up on either side?
Those are the 4 Galilean moons, Io, Callisto, Europa, and Ganymede.
Why are they called Galilean moons?
An Italian mathematician named Galileo in 1610 was the first man to see them with a telescope. In fact, it's believed that Galileo was the first to use a telescope to view the heavens. He was surely the first to record his observations.
Galileo invented the telescope? Nope. Can you tell a story of that Dutch guy?
Sure, but let me tell your friend what it was like before there were telescopes. Prior to the invention of the telescope, everyone believed that the Earth was the center of the universe, and that the sun, moon, and planets orbited around it. Then in 1543, Nicholas Copernicus proposed a different model with the sun, not the Earth, at the center. This was a radical idea, but he had no evidence to prove it. Nearly 65 years later, in 1608, a Dutchman named Hans Lippershey took 2 small pieces of glass and fixed them in a tube, creating a spyglass. A few months later, Galileo read accounts of it and built his own. On a clear evening in January 1610, he pointed it toward Jupiter. The telescope's narrow field of view made it difficult for him to find Jupiter. But when he did, he saw 3 stars next to the planet, one to the right and 2 more on the left. He watched these points of light over several nights, noting how they changed their position. He determined that they were moons orbiting Jupiter, not the Earth. This became the first observational evidence that the heavens worked differently than what people had imagined up to then. Copernicus' theory, that we orbited the sun was eventually proven using Galileo's new window on the universe, the telescope. And he saw more than just Jupiter's moons. His telescope magnified enough for him to recognize that there are mountains on the moon, spots on the sun, and that Venus goes through phases like our moon. He also saw that the Milky Way was made up of thousands of stars. Now, would you like to look at Saturn? Sure. Okay, give me a minute. Okay, take a look.
Wow, is that real?
It's real.
Did Galileo see Saturn in his telescope?
Yes, but he only saw an oblong point of light because his telescope lacked the resolution to see the rings. He described it as a planet with ears. The Dutch astronomer Christian Huygens, using a 23-foot-long refracting telescope, revealed that Saturn is a ringed planet and discovered its largest moon, Titan.
Was his telescope as big as this one?
It was quite a bit longer, but the aperture of the lens was just a few inches in diameter.
Why was his longer?
It has something to do with how light focuses through the lens. Something about color.
Aberration. That's right. When you view a bright star or planet through a simple refractor, you see a colored ring of blue and yellow around its edges. By increasing the focal length of the telescope, or making it longer, the less aberration you get.
But I only see a ring around Saturn, and it's not blue or yellow.
That's because her telescope is not a refractor. It's a reflector.
Shortly after Huygens made his long refractors, a man named Sir Isaac Newton did some experiments and figured out that the color aberrations were produced when the light passed through the lenses. So he found a way to use a mirror to focus the light just like a lens, but without the color aberrations. Now, do you want to see some real color?
Sure.
Okay. I'll point the telescope over here to a pretty sight. Albury A and B, a binary star system, which means these two stars appear extremely close. In fact, with your unaided eyes, it appears as a single star in the sky.
I see two stars, but they're not the same color. One is blue and one is gold.
That's because each star is of a different temperature. I learned that last year. When you look at a candle flame, you see it go from blue near the wick to almost red at the top. Each color relates to the temperature of the flame at the point. The top of the flame, the red part, is hot, but the blue part is really hot.
Right again! Newton was involved with figuring that out as well. Remember the light passing through the glass lens that created color aberrations? Well, Newton passed light through a prism and figured out that colors of the rainbow corresponded with different temperatures. The blue portion of the rainbow, or spectrum, is warmer than the red. So not only did Newton figure out how to build a telescope using a mirror as a lens, removing color aberrations, he also started the study of light, called spectroscopy. These unique discoveries are utilized on telescopes all over the world every night, even on the 10-meter mirror telescopes in La Palma and Hawaii.
10 meters?
That's like over 30 feet. What's it like looking through one of them?
Astronomers don't look through telescopes that big. They use devices called detectors. Detectors take the focused light and either image it into a digital photograph or break the light up into a spectrum. Now, a photograph can tell you a lot about an object, but a spectrum can reveal the unseen. See, when astronomers study a spectrum from a star, they can deduce a lot of information about it. By comparing the observed spectrum to those created in a lab, they can tell how hot it is. They detect what elements are in the star's upper layers. They can also observe the star's apparent motion by how much the spectrum is shifted. Have you ever heard a siren from a police car or ambulance change its pitch as it drove by?
Sure.
What you heard was something called the Doppler effect, where the sound wave was compressed as it came towards you and then stretched as it went away. This same effect can be seen in spectra of stars that are in motion coming toward or going away from the observer. This effect can also be used to observe motion in galaxies.
Galaxies? Don't we live in a galaxy?
Yes, it is called the Milky Way. But did you know that we've only known that for less than 100 years?
Why did it take so long for us to figure that out?
Before the 20th century, astronomers thought the universe consisted of a flat disk of stars with the Earth and the solar system residing in the center. An astronomer named Carolyn Herschel even made a map of this disk. Because telescopes of the day didn't have the resolving power to see individual stars and other galaxies, they thought the patches of light, which they called spiral nebulae, were part of this immense disk. It wasn't until the 100-inch telescope atop Mount Wilson was built did astronomers see individual stars in the disks of the spiral nebulae. An astronomer named Edwin Hubble used this telescope to observe a special type of star called Cepheid variables, and was not only able to determine that spiral nebulae were individual galaxies that he called island universes, but that they were extremely far away. Look here, this is the closest major galaxy to ours. It's called the Andromeda Galaxy.
Didn't Hubble also determine that the universe was expanding?
Yes, he did. The expansion that he observed and later observations of cosmic background radiation in the 1960s confirmed the model that the universe was created in a Big Bang.
Is that why they named the Hubble Space Telescope after him?
That's right. When NASA launched the Hubble Space Telescope, they knew that the telescope would reveal a universe unseen by land-based telescopes of the day. See how the stars twinkle?
Yeah.
Our atmosphere causes that. And regardless of how big you make a telescope, the limiting factor in what a telescope can see is the air between it and space. So when they put a telescope in space, astronomers knew that they were in for some surprises. The Hubble Space Telescope revealed the formation of stars and planets, the magnificent remnants of stellar death. It has shown us that the universe is dynamic and not stagnant. But what it really showed us is that the early universe was different than the one we live in today.
What? What do you mean, the early universe? Isn't it all the same? How can we see the early universe if we're older?
Great question. See that star over there? That's Vega. It's about 26 light years away. That means that the light which that star generates takes 26 years to travel to us. So we see it as it was 26 years ago. Now that star over there is called Deneb, and it is 3,600 light years away.
So that's the way it looked 3,600 years ago?
That's correct.
And how old is the light from the Andromeda Galaxy?
Over 2 million years. So telescopes are not only optical instruments, they can be used as time machines. And the Hubble Space Telescope looked back to over 13.5 billion years when it took an image called Ultra Deep Field. This image revealed a very different universe than we live in today. shows small young galaxies colliding and merging to form larger galaxies, which led to the galaxies that surround us today.
So now that we have telescopes in space, astronomers don't need telescopes on Earth anymore, right?
That might have been true if they hadn't developed a process called adaptive optics. Astronomers and engineers can now measure the distortions caused by the atmosphere in real time and subtract them out before the light from an object reaches the focal plane of the telescope. Because of this technology, large aperture telescopes that operate around the world can now rival the resolution of the Hubble Space Telescope. Even larger land-based telescopes, the size of football fields, are planned to be constructed in the next 10 years and will look even further back into time.
What do you think they will see?
I'm not sure, but I want to be the first astronomer to use that telescope.
Good for you! Astronomy is filled with puzzles and unsolved mysteries. The recent discovery that the universe is accelerating in its expansion is one that will need lots of observations to figure out what drives it. Dark matter and the physics that hold galaxies together is another one. But the one that excites me the most is that we are close to having the power to observe Earth-like planets around other stars and should be able to detect life on those planets. Who knows? Maybe you will be as famous as Galileo is today because of two small pieces of glass that he turned to the heavens, launching humanity on the ultimate voyage of discovery.
Hope you enjoyed two small pieces of glass. Yeah, clap your hands for the story. I like the music for this one. Always reminds me of Christmas music. Or Harry Potter. Yeah. We had John Williams.
Christmas, everyone! Ho, ho, ho!
I'm
beginning to feel a lot like Christmas.
So, in the center of the room, you'll see our optical mechanical projector, which is a first generation Chronos. And this projector is 19 years old. The cylinders you see on the ends are what project the sun, the moon, and the planets. And on the main star ball, we have 32 individual lenses to project the night sky in a pattern similar to the pattern you see on a soccer ball. And I turned off the killer death laser, so don't worry, I won't vaporize anybody during the show. Yeah, well, yeah, I can't get rid of our numbers. So, all right, I'm going to go ahead and put the projector in position for sunrise this morning. And I'll go ahead and bring up the Milky Way, the stars, the sun, the moon, and the planets. And our cardinal points or directional points, as you know, are south is in front of us, west is to your right, east is to your left, and north is behind you. So this is approximately 6:51 this morning, standard time. So if you were outside, you probably saw the moon directly overhead. The moon's in a waning gibbous. It's last quarter. It's like a few hours away from being last quarter. So technically, it's a waning gibbous still, but not for very long. The other coordinates, we have the azimuth that goes along the horizon. You have the zenith directly overhead, and you have the meridian, which follows the point from the southern point of the horizon to the zenith, and then back to the northern point, and it basically separates the eastern half of the sky from the western half of the sky. So if you're out this morning, you saw Orion the Hunter over toward the west, because we're now reaching that point in our orbit where we're going to be able to see Orion in the evening. So I'll go ahead and I'll start time, and I'll dim the sun a little bit so it's not too obnoxious. There's Venus, so we're going to only see Venus in the morning sky for a few more weeks, and then it will disappear to the glare of the sun, and we won't see it for almost 2 months as we try to catch up with it, but we won't because Venus is going faster. So it'll be in the evening sky starting in late December, early January. So let's see, a couple other coordinates in the sky. So I'll go ahead and get rid of the meridian, the azimuth, and the zenith. So you have Spica right here, which is the brightest star in Virgo, the maiden. And you'll see Mars is right next to Antares. Mars and Antares are often confused for each other. Nope, I'm sorry, that one's Mercury. That one's Antares. Mercury is right, gosh, Mercury and Mars and Antares, they're all like clustered together. There, yep, that's Mercury. So Mercury is now on its way this way, so it's in retrograde, so it's going to get dimmer and dimmer until we can't see it anymore, and Mars is on the opposite side of the solar system, so that in itself is also harder to see now. But Antares means rival of Mars, and the rest of my stars here will appear shortly. Let me nudge latitude, there we go. So Antares means rival of Mars because they do have similar colors, but Mars is red because of the rocks on the surface, giving it that distinct red color because the iron has made the rocks look rusty. And then you have Scorpius and Scorpion, and you have Sagittarius. So if you drew a straight line through them all, you have the ecliptic, which is the imaginary path the sun appears to trace in the sky during the course of the year. So I'm going to have John bring the lights the rest of the way down. So as the sun sets, it will get darker, and you'll be able to see more stars. And the path, the constellations along the ecliptic, those are the constellations of the zodiac. So this is a good time to go out and look for the Milky Way if you have not been able to spot it, because the densest part of the Milky Way is in this region here. Let me go ahead and get rid of the ecliptic and our zodiac. So this is now about 5:50, almost 6 o'clock in the evening. So it'll start to get dark pretty quickly because we're now on standard time. But the Milky Way, this band of light, is our perspective from the inner part
from our location in the galaxy. So the Sagittarius arm is that way, and the Orion arm is on the opposite side of the sky. We can't see right now, but yeah. All right, so let me go ahead and I'm going to rotate us over toward the east. So clap your hands if you're still awake. Okay. So the constellations that you usually see right after sunset in autumn are all related in the same story. We have Cassiopeia, Andromeda, Pegasus, Perseus, and Cepheus, and we also have Cetus. Cetus is the sea monster, also known as the Kraken. So I'm going to aim us toward the northeastern part of the sky. And when I started working in Planetarium, many of you know this story. I started as a volunteer when I was 14 years old because they didn't have child labor laws in Miami back in the 80s. I'm kidding. But I started as a volunteer, and they taught me my constellations. And although I knew a few of them, I didn't know all of them. But the technique that they showed me is one I always like to share with our audiences. And that is, if you can find a constellation you're familiar with, you can use stars from that constellation to find all the others nearby. So we have a fairly bright constellation in the northeastern part of the sky known as Cassiopeia. And it looks kind of like a number 3 or a W. And it represents the beautiful queen of Ethiopia. And the stars are Kaf, Shedar, Navi, Rukba, and Sagan. There's an itty bitty little star right there that could be the seat of the chair that she is sitting in. So here is Cassiopeia. Ta-da! And she was very beautiful, and she was very vain, and she often would tell people how beautiful she was. Well, she made the mistake of telling people that her daughter Andromeda was more beautiful than Neptune's daughters, the Nereids. And of course, Neptune took offense at that, so he created the Kraken to destroy their kingdom. Well, Cepheus was perplexed by why all of a sudden the sea monster showed up, so he went to the oracle and asked, hey, what's going on? And the oracle said, yeah, your wife was bragging about how beautiful your daughter was, so there's a sea monster that's going to destroy your kingdom, and the only way to get rid of it is to get rid of the sea monster. And to get rid of the sea monster, wait, I just said the same thing twice. Yeah, sacrifice your daughter Andromeda to the sea monster, and the sea monster will go away. So that's the only way to get rid of it. All right, so fortunately for Andromeda, she will be rescued by Perseus, who will defeat the sea monster using Medusa. Now Medusa tried to steal Athena's boyfriend, so Athena turned her into a gorgon, which has snakes for hair. So I'm going to show you Perseus is up here, and so is Cetus. So we'll start off with Pegasus, the flying horse, and Cepheus, they're right next to each other. So let me nudge us over this way. So if you take Kaf and Shedar and draw a line this way toward the northeast, you'll see something that looks like an upside down house. This is Cepheus the king. His head is down here, these are his feet, and the throne that he's sitting is right here. So he has one leg there and one leg there. You have to use a lot of imagination. But he's upside down as Cassiopeia is. This star, Eri, will one day be our North Star. As you know, our North Star right now is Polaris, and this is the Little Dipper, also known as Ursa Minor, the overfed squirrel. The reason Polaris is special is not because of its brightness, it's because that even though it's the 49th brightest star in the sky, our axis of rotation points in that general direction right now. So all the stars appear to go around it in a circle. So it's great for celestial navigation. Now, there is actually a giant circle that Earth's axis traces in the sky, and it takes 26,000 years for it to make one complete wobble. This is what we call precession, and it's a very, very slow process, but it's a physical property that rotating bodies have that in order to conserve angular momentum, they precess. So you probably notice that when you spin a top, as the top slows down, it begins to precess or wobble more and more to conserve its angular momentum until it falls over and stops. Earth won't fall over, but because we're dragging the moon around and we're being interacted by the sun and Jupiter and Venus to a lesser extent, we precess. And again, it takes 26,000 years for us to precess. So in 2,000 years, that point will be pointing toward Eri. 5,000 years ago, it was pointing toward the star Thuban, which is in Draco the Dragon. You can barely see it right there, but it was actually closer to being a North Star to us than Polaris was, but Polaris is the brightest of them in the precession circle. All right, so enough about the precession circle, but one of the other stars in this area is Delta Cephei. Delta Cephei is this particular star right here, and that is the star that everybody was studying. It's right next to Zeta Cephei, but Delta is the Delta Cephei. They are a specific class of star where the luminosity and the change in that luminosity over the period over the star's life is very predictable. And Henrietta Leavitt noticed that when she was studying the stars in the Magellanic Cloud, the Large Magellanic Cloud specifically. She was noticing that a lot of those stars were Cepheid variables. So that gave Edwin Hubble and a lot of the other astronomers that followed Henrietta Leavitt the ability to calculate a standard candle for star distances. So that's how we now know the distances to various galaxies, as you heard in the show earlier, and also the shape of our own galaxy. So that's a particular star that you might want to check out one of these days. Now, the other constellation I want to show you is Pegasus. So remember, we used Cassiopeia. We went this way to find Cepheus. If you take these up here and go upward, you'll see the great square of Pegasus almost directly overhead at this point. So I'm going to run time backwards a little bit so you don't get a crick in your neck. But the stars in the great square of Pegasus, you have Markab, Shiat, Alpheratz, and Algenib. Then his head is right here, and this is his neck. You have Enif, Beham, and Homam. They are the stars that make his neck. And then you have Matar and Salibari. Matar is one kneecap, and then Salibari is the other kneecap. And for those of you who are fans of naval vessels, the USS Matar was named after that star right there. And it was a cargo vessel that was used during World War II. And it was actually built and stationed in Jacksonville, Florida. For those of you who like stellar and military trivia. The United States Navy named a lot of their ships, the Crater-class starships, listen to me, the Crater-class ships after stars. I'm a big Star Trek fan, and yeah, so the two merge in my brain. All right, so in the advanced time, we'll go back. So here's a picture of Pegasus, so you can find him. Ta-da. All right, so I'm going to advance time back to where we were before, so that Perseus is visible. Okay, so the star Alpheratz is one that is shared with Andromeda. So you have Alpheratz, Merak, Almach, and then this last one down here whose name I forget. But you go 1, 2, 3. I know. Well, I've memorized 90 of the stars. I'm trying to remember some of the others, but I don't practice this one as much, so I forget. But anyway, and on this side you have 1, 2, 3. So this is one leg here, and that's another leg here. This is her shoulder, and that's one arm there, and that's another shoulder, that's another arm there. She has very skinny shoulders. Now this fuzzy blob right here that looks like it could be the glow of her cell phone. You know what that is? That's the Andromeda Galaxy! Yay! So now you know how to find it. If you can find Pegasus and go 1, 2, 3, this star here, you go 1, 2, 3, and you can find it. But you have to be out where it's dark enough where you can see the Milky Way. Because if you can't see the Milky Way, it's going to be really tough to find the Andromeda Galaxy. So one of the techniques that a lot of astronomers use, which you probably already know since you're a member of an astronomy club, use the technique of averted vision. So if you look at this star here, you can kind of see the Andromeda Galaxy in your peripheral vision. Same with the double cluster down here. Usually for the fainter objects, if you look at something bright that's not in that direction, you can kind of get the other fainter stuff. It is more challenging to aim a telescope at something that faint, but with all the technology we have nowadays, if you have a computerized telescope, just say, I want to look at the Andromeda Galaxy, and the telescope will go, bing, there you go, enjoy. So Matt knows all about this, don't you, Matt?
He's asleep.
Matthew Peters, are you asleep? Of course I'm asleep. It's dark in here. Football practice. Okay, so now to find Perseus, which is right below Andromeda, you can use both Cassiopeia and you can use Andromeda. Depends on which one you prefer. So if we use Andromeda, remember how we found the Andromeda Galaxy? We went 1, 2, 3, and then this one here, Andromeda Galaxy. But if you go 1, 2, 3, and 4, you can draw a curve all the way down to Merfak. Merfak is the brightest star in Perseus. You can also take Navi, and Rukba and go past the double cluster, and you can find Murfak that way. Now Murfak is Arabic for elbow, but I don't really think that looks like his elbow. It almost is it's in the center of the constellation, so it's kind of his heart. So he has one leg that goes this way, and another leg goes that way, and an arm that goes past the double cluster holding a sword upward towards Andromeda's foot. So here's Perseus, ta-da, and here is Andromeda, ta-da. Now, you're probably wondering why he's holding the severed head of Medusa. Well, Perseus was prophesied to when he was younger that he would rescue a young maiden, but he had to defeat Medusa first. And the only way he could defeat Medusa was to behead her. But the thing is, if you look directly at Medusa, you'll turn to stone. So he was able to use the reflection of Medusa in the shield that Athena had given him. Ironically, Athena was the one who turned her into a Gorgon. But anyway, he looked at her reflection and severed her head, put it in a bag, and said, hey, I guess this is how I'm going to do this. So he flies by on Pegasus, seeing Andromeda in distress. He goes near the sea monster who's on its way to, attack Andromeda on the shore. And he takes the head of Medusa out of the bag and shows it to the sea monster. The sea monster goes, oh my gosh, that's so ugly. Poof, and instantly turned into stone. And thus rescuing Andromeda and the whole kingdom, and everyone lived happily ever after. Yeah. It's a very abridged story because I want y'all to be able to go home. Okay, so here's how you find Cetus, the sea monster, because it's the only one in this group that I haven't pointed out yet. So, Cetus is a little bit further to the east, and I'll advance time another 30 minutes, so it's higher above the horizon. Now, here's how you find Cetus, and let me advance time a little bit further. Okay, so here's Perseus, which is also the radiant for the Perseid meteor shower in August. But remember, you take Cassiopeia and you go downward to Murfak. You can take Andromeda downward to Murfak. And if you follow this trail of stars, there's the Pleiades, the 7 daughters of Atlas. And if you keep on going, you're going to see what looks almost like a pentagon shape of stars. These are some of the stars of Cetus the whale. You have Menkar, Myra, and Dipta. Dipta is also known as Deneb Katos, which is the tail of the Kraken. So I like to draw it as a whale. So this is the tail of the whale here, and this is its body, like that. But you can also draw it as a kraken, I guess. So the head of the monster is here, and the rest of its body trails off that way. So depending on your level of imagination and how much you drink before you go outside to look at the stars, you can make up whatever you want. Because I used to think this looked like the T-bone of a pork chop. Because I like pork chops. Yeah, so, make up your own stuff. And then, the great score of Pegasus can be a waffle, but I mean, there's no, if there was more detail in here, you could really say it was a waffle. But it's a square, it's a brownie. Yeah, it's a square. That's why they call it the great square of Pegasus. Okay, so I'm going to advance time a little bit further into the latter part of the evening. So as you know, as Earth orbits the sun, the stars rise or appear to rise 4 minutes earlier each night. So after several weeks have gone by, you'll start to see winter constellations in the early part of the evening. So now I have it set for 9 o'clock, and now you can see Auriga the Charioteer, which is these 5 bright stars. You have Capella, which is an A-class star. It's a yellow, but it's a big yellow, so it's a G1 or G2. It's not a small one like, no, we're a G2-5. So it's a giant. It's not a super giant. So it doesn't matter the luminosity and classification. It's a yellow star, and it's 42 light years away. Just run with that. Okay, so we have Calnan, Mahassan, Elnath, and Hassala. Hassala used to be called Kadilinon, but the International Astronomical Union decided to name it that instead in 2016. And then you have the kids, Almaaz, Saklateni, and Sadatoni, those 3 there. All right, so if you go forward a little bit more in time, you'll see Orion the Hunter. And Orion is another constellation that's great for finding other objects in the night sky. So if you were to go outside at 11 in the evening, Jupiter comes up at about 10:20, and Sirius comes up just at about 10:45, and at 11 o'clock, everybody in the winter sky that we care about is above the horizon. So Orion the Hunter is here. You have Alnitak, Alnilam, and Mintaka. Draw a straight line upward, you'll see Aldebaran, and then the Hyades right here. Go from Aldebaran to Tiaguan, that's one horn. Go from Ain to Elnath, which is one of the stars of Auriga. That's the other horn. And then I heard that, Lisa. And the Pleiades are right there. It's not so much showing off, but it's if I don't do that, I'll end up forgetting the star names. So it forces me to retain that memory because I'm not as young as I used to be. Am I, John?
I'm not saying
Yeah. So anyway, all right. Then Gemini is right below that. If you take Rigel, go through the belt stars to Betelgeuse, you pass Alhina, and you have Castor and Pollux. Castor and Pollux, and I think that one's Wasat. So Castor's here. You draw his body's this way, his foot's there, and his arm's there, and Pollux is here, and you draw a line down that way. That's his body, that's his foot, and his arm's there. And Jupiter, their dad, is hanging out with him right now. Jupiter takes 12 years to orbit the sun, so the next time Jupiter will be in this part of the sky will be in 2038. Yeah. Golly. 2037, 2038. Yeah. So I will be 2 years old on Jupiter. No, 5 years old on Jupiter next year, 2 years old on Saturn. So Cancer the crabs down here. This is the beehive cluster. You'll be able to see that at about 11:30. And Procyon is over here. Let me go ahead and turn on Gemini so you can see Gemini. Procyon and Gamesa are Canis Minor. Sirius down here is Canis Major.
You're kidding.
No, I'm serious. It's only like 8 light years away. You don't know that. Alrighty, so I'm going to go ahead and nudge us a little bit more east. The moon is going to rise at a little after midnight tonight because it'll be at last quarter. And as you know, the moon doesn't give off its own light, it just reflects light from the sun. So what you're seeing is sunlight bouncing off the daytime side of the moon, and the nighttime side is the dark side of the moon. And it's in Leo the lion. So here's Leo, and the Big Dipper will be over here to your northeast. So by the time you go outside, let's say at about 5 in the morning, you'll be able to see all of the Big Dipper quite easily. So now we're at 3 a.m. and now all the Big Dipper is above the horizon. Here's Ursa Major, and here is Leo. Ta-da. So they look like they're marching across the sky together, and the moon is in the way. All right, so it is 8:52, and I'll advance time a little bit further so you can see Virgo rising. But if anyone would like to see their birthday on the projector, I can do that now before you leave.
James, I have a question.
Yes, what is your question?
When the comet gets closest to us, where in the sky might we be able to see it? That the odd one that's...
Oh, yeah. Yeah, Comet 3I Atlas, which is the third interstellar comet that has passed through our solar system, is supposed to be in Virgo most of its brightening. It's leaving the solar system and it's going through Virgo. So here's Virgo, here's Spica. It's supposed to be going up in this direction, I believe. I'm going to have to look at my star chart again to make sure I'm in the right area. But its magnitude is so faint. I think they took a picture of it right after perihelion about a week ago. But now it's getting to the point where it's well below naked eye visibility. I made an episode about it, but I didn't post it on the sky above us just because it's below naked eye visibility, so most people wouldn't be able to even see it. And you have to be out where it's really dark. Comet Lemon was in the evening sky earlier. We had 2 comets coming through the solar system at the same time that were of interest. Comet Lemon, though, I think that one's gone already. Or is it still out there? Has anyone here looked at Comet Lemon?
Yes, it's in the evening sky in the west,
Okay.
low down, beneath Ophiuchus,
Okay. You know its magnitude offhand?
getting down to its fifth.
Fifth? Okay. Yeah, so it's barely naked eye. Okay. Cool. I can't think of anything else to say.
And then meteors.
Oh yeah, meteors. Meteor shower. We have the Leonids coming up soon, so the moon's not going to be in the way by the time we have the peak of the meteor. Let me go ahead and set this to the 16th. That's where the moon's going to be on the morning of the 16th. So if you're going to watch for the Leonids, they'll be radiating from Leo, and this is about 5:30 in the morning. So if you go outside, you should get a good view of it this year. We're not near the peak, but we're getting there. In 2033, I think we'll be near another large display because the comet that makes it has a period of about 33 years. Boom, boom. All right, I'm going to put the projector in a vertical position. So you can take pictures of it if you like. And I'm going to bring the lights up brighter around the projector. John's going to bring up the red lights. But I want to thank y'all so much for visiting the planetarium. It's our last planetarium visit of the year for our meetings. We have our Christmas party next time. And I should be able to go because it's on a Sunday. And I will be in town because my 20th wedding anniversary is on December 3rd, so I'll be out of town that day. But that's a Wednesday, I think it is this time, or Tuesday. But anyway, we'll go ahead and bring the lights up a little bit brighter, and I'll turn it over to Dave, our president. Yeah, we can go ahead.
Hope to see you Friday at Chiefland's Art Party, and it's not there, or perhaps both. Lisa needs helpers and telescopes for Saturday night at Rosemary Hill, so let her know if you can help there. And then we hope to see you at the holiday party. I just want to let you know it's been an honor and a pleasure to be your president the last 2 years and to run the